Alright, in this video, the objective is to be able to identify multiples and find the least common multiple given a set of numbers. And so we'll just break that word down real quick. The least common multiple, sometimes we refer to that as the LCM for the initials. And if you think of the word multiples, the multiples are a number. For example, the multiples of 3 are 3, 6, 9, 12, 15, 18, and so on. The multiples of 5 would be 5, 10, 15, 20, 25, 30, and so on. Those are multiples of a number, so they're numbers. If you want to say the multiples are a number of, is the number added again to itself many times, or that number multiplied by another number. That would be the multiples. So when we have a set of numbers, for example, two or more different numbers, then sometimes eventually when you think of all of their multiples, then they will share common multiples. They will share more than one, but we're looking for the least common multiple. So, for example, 3 and 8, let's say, you have 3, 6, 9, 12, 15, 18, 21, 24. And 8 would be 8, 16, 24. They both share a multiple of 24, and that is the first multiple they share. So that's the least common multiple. So I'm going to show you 3 ways to do this. Again, I prefer the cake method. I'll show you that last, but I'll show you the other 2 ways just in case. Or if you've been taught somewhere else these other ways and you like them better, I'll still just kind of refresh your memory on that. So let's take the 2 numbers, 24 and 15. And now the first method I'll show you is called the list method. So you just simply list all the multiples of 24 or several multiples of 24. So we have 24, 48, and next would be 72, and next would be 96, and I believe next would be 120, and after that would be even 144. And if you list the multiples of 15, you get 15, 30, 45, 60, 75, 90, 105, and 120, and we could go on, but we can already see that 120 is shared, and those are the first multiples that's shared. So that's the least common multiple of the 2 numbers 24 and 15. Now let me show you another way. I'll just use those same 2 numbers. You can also use the factor tree method. So you factor, take the prime factorization of 24, and you get, we can just do, 6 times 4 will be fine. And then you have 3 times 2 times 2 times 2. And if you factor 15, you will get 3 times 5. So you list those out. 3 times 2 times 2 times 2, or 2 times 2 times 2 times 3, same thing. And 3 times 5, okay, you circle whichever ones they have in common. In this case, they only share one set of 3s. If this was 5 times 2, you'd have another set of 2 circled. And then you just simply count this once, so you do 3 times 5, and then you multiply this, you count this as once, you multiply it times everything else that's not doubled up. So 3 times 5 times 2 times 2 times 2, and that gets you, let's see, 15 times 2 is 30, 30 times 2 is 60, 60 times 2 is 120 gives you the same solution. Now, again, the way that I like to do this is the cake method, and it makes it very simple for you. And so we just do our cake. We have 24 and 15, and we can factor out a 3. And so if we factor out a 3, we're left with 8 and 5. And actually, since nothing else factors out, we can just leave those on top. So here we have to find the least common multiple using the cake method, we just simply multiply everything that's on the outside. If you accidentally put this here and there was nothing to factor out to go higher, you would still multiply this times the top numbers. Okay, so 3 times 8 times 5. Let's see, we use the commutative property to make this math a little easier. Let's do 8 times 5 is 40, and 3 times 40 is 120. Again, the least common multiple. Not to be confused with the greatest common factor, which is only the numbers on the side. All right. Let me do a few more using the cake method here. Let's say we have the numbers 6 and 10. Well, I do my cake, 6 and 10, pull out a 2, I'm left with 3 and 5. So to find the least common multiple, I just simply multiply these numbers, 2 times 3 times 5, and we find out that the least common multiple of 6 and 10 is 30. And you could double check that with the other methods that I just went over if you wanted to. Okay, let's do a few more. How about 16 and 24? Well, here's the cake, 16, 24. I can pull out a 2 for sure, left with 8 and 12. I can put out 2 and a 4. Since I'm not doing prime factorization, I can go ahead and pull out a 4 if I want to. Or again, some people could see that I could pull out an 8 from here. It's okay. If you're doing the prime factorization as well, these numbers have to be prime. But if you're not, you can just pull out whatever number that you see. And we're going to be left, if we pull out a 4, we're going to be left with 2 and 3. So to find the least common multiple, we'll multiply all of the outside. 2 times 4 times 2 times 3. And let's see, what do we have here? 2 times 4 is 8. 2 times 3 is 6. 6 times 8 equals 48. That would be our least common multiple. And last but not least, let's try the numbers 14 and 20. I can pull out a 2. And I have here 7 and 10, and 2 times 7 times 10. Let's use the commutative property again, and 2 times 10 is 20. 20 times 7 looks like it's 140 would be the least common multiple. All right, that is the lesson for today. So please, as always, write a summary that's going to help you remember how to find the least common multiple given a set of numbers. Thanks for watching.